Okay, we are a couple minutes in, so we'll go ahead and get started. Hi everyone, my name is Samantha. I'm a Girl Program Specialist with Girl Scouts Western PA. Welcome to another virtual patch programming. Today we are doing Mad Science. Our Weird Science was such a hit, we've decided to do a sequel to that and do Mad Science. So as always, we're going to do three things. We'll discover, we'll connect, and we'll take action. For our discover, we're going to discover and try out some fun science experiments. For connect, we're going to learn the reason behind those experiments and why certain reactions take place. And then for our take action, we just want to share the new knowledge we learned today, whether that's sharing this experimenting today with friends or family, putting on your own science show, or maybe even making a science experiment guide with all these experiments and the reasons why they happen. And you can always add your own experiments too. I think that would be great. I'd love to see what you guys come up with. All right. So I think without further ado, we'll go ahead and get started on our first experiment. So our first experiment is called walking water. So you'll need tissue paper or paper towel. I've tried this with both. The paper towel does work a little better. So I have half a sheet of a paper towel. You'll need some food coloring, 2 different colors, preferably primary colors. So the 3 primary colors, yellow, red, and blue. You'll need 2 of those. Water, and then 3 small glasses. Mine are about this size. And they're all the same height. I think it works best if they're all the same glass, but if you have different glasses, that works too. I'd love to know what the difference is. So the first thing we are going to do is pour water into 2 of the glasses. Let me move these back a little bit so you can see. So we're going to take our 2 glasses on the end and we're going to fill them pretty full, not all the way to the tippy top. Just about there looks good to me. I'm going to do that on both side cups. There we go. Okay, and then I'm going to take my paper towel. Actually, before I do that, I'm going to take my food coloring. So, do you guys want to use, what colors do you want to use? We have 3 and we only need 2. Yellow, red, and blue. What colors do we want to use? So these are the 3 primary colors, which means when you mix any 2 of them together, they're going to make a new color. So red and blue will make purple, red and yellow will make orange, and blue and yellow will make green. Someone says, does it matter if it's warm or cold water? It shouldn't, but if you want to try it both ways and see if there's a difference, I'd be interested to see what happens there too. All of these experiments that we're doing, feel free to change them a little bit, see if something different happens from what I'm doing. That's all what science is, experimenting different ways. All right, my first one was blue and red, so let's go with that and make purple. I'm just going to put a couple drops. I think 3 should be good. Give it a little stir with a spoon. Yeah, that's really blue. Okay, and then red in my other one. I think 2 drops would be good for that one. Give it a little stir. Okay. And then we're going to take our paper towel. We're going to rip this in half again. So that about this size. And we're going to just fold it a couple times. Maybe about 3 times, so it's about this big. And this experiment is called walking water, so I'd love to know in the comments what you think is going to happen. We're going to put each paper towel in these cups, and we're going to put the other end in the middle cup. What do you guys think will happen when we do that? is about a good size for your paper towel. Any ideas? Sorry for those of you that are saying yellow and blue. Feel free to try this with whatever colors you like. I'm going to go with blue and red. Any ideas? A hint is that it's called walking water. Okay, well you guys are thinking and typing that in. Go ahead and put one end into the blue. You can see it's already starting to creep up. Water will go up the towel and make purple in the middle cup. I don't know, let's see. You can already see, hopefully you can see the water creeping up. Move it forward a little bit. It's going to take just a few seconds. And the more water you have in the cups, the faster it's going to move. And I do think that paper towels move faster than tissue paper. Oh, there we go, they're starting to drip in. So I did this one first because we're going to start watching it, and then I'm going to set it to the side while we do the other experiments, and then we'll check back with it again at the end today and see where we are. So you can see already in the middle there's a little bit of water. And I'm going to, while we look at that, I'm going to explain a little bit about what is happening here. So this comes from the stemlaboratory.com. It says the colored water travels up the paper towel by a process called capillary action. Capillary action is the ability, I have a little lab assistant. He wants my water. Where was I? Capillary action. Capillary action is the ability of a liquid to flow upward against gravity in narrow spaces. This is the same thing that helps water climb from a plant's roots to the leaves in the treetops. Paper towels and all paper products, like tissue paper, are made of fibers found in plants called cellulose. In this demonstration, the water flowed upwards through the tiny gaps between the cellulose fibers. The gaps in the towel acted like capillary tubes, pulling the water upwards. So I'd love to know why you guys think the paper towels work better than if we use tissue paper, which I did, and it didn't go quite as fast. So I'm curious what you guys think why that happened. The water is able to defy gravity as it travels upward due to the attractive forces between the water and the cellulose fibers. The water molecules tend to cling to the cellulose fibers in the paper towel. This is called adhesion. The water molecules are also attracted to each other and stick close together. So as the water slowly moves up the tiny gaps in the paper towel fibers, the cohesive forces help to draw more water upwards. At some point, the adhesive forces between the water and the cellulose and the cohesive forces between the water molecules will be overcome by the gravitational forces on the weight of the water in the paper towel. When that happens, the water will not travel up the paper towel anymore. This is why it helps to shorten the length the colored water has to travel by making sure your paper towel isn't too tall and making sure you fill your colored liquids to the top of the glass. So we're going to see what happens at the end here. Someone says paper towels are stronger. Yes, their fibers, I think, hold on to the water stronger, which is why that happens. So I think we'll leave this. You can already see what's going on in the middle here. But we'll leave this and check back on it again at the end of our live today. Okay. So let's move on to our second experiment. And this one is called Storm in a Glass. So you will need a tall clear glass. I have this pretty big mason jar. Someone says their blue and red are making purple, and it's so cool. I agree, it is very cool. You'll need some shaving cream. I'm not sure if this experiment will work with other cream, like whipped cream or mousse, but if you have that and you're doing that, I'd love to know if that works for you. We'll need some water again, and some food coloring again. I think I'll go with blue this time, but feel free to use any color you like. Okay. Oh, we'll also need another spoon and another small glass. Okay, so we are going to fill this glass here about half full. It doesn't have to be perfect. About halfway will be good. And again, it doesn't matter if it's warm or cold water. Either one will work. I think mine's about room temperature. Might be a little bit more than half. That's good. Close enough. Again, it doesn't have to be perfect. Okay, and then we're going to take some shaving cream, and we're going to put it on top and fill it to about 3/4 full, so not all the way full, maybe about here to the rim. And it says we can take our finger and just sort of smooth it so that it's all one level. Get a little messy. Make sure it covers the entire top of the water. You don't want any holes. Paper towel here for just this purpose. And yes, if you need some more time to work on your experiment, feel free to pause this video and start again whenever you're ready. Back at my instructions. Okay. Add a little bit more, just so I don't have any holes. Okay, that looks pretty good to me. I think we're pretty smooth all the way around. And then we are going to take a little bit more water and pour it in a smaller glass or cup. This should be enough. It says about half a cup, but it doesn't have to be perfect. And then we are going to put a couple drops of food coloring. I think about 4 drops should be good. Go ahead and use the spoon to stir it again. This nice dark blue color, but you can use any color you like. I'm using this because this experiment is called Storm in a Glass, so I'm using my blue because it reminds me of a storm. Okay, so we are going to start taking spoonful by spoonful, gently adding some water on top of here. And I'd like to know what you guys think will happen as we start adding water on top of our shaving cream. And another hint, this experiment is called Storm in a Glass. So what do we think is going to happen when we start adding the water to the top of the shaving cream? Any ideas? I'll let you guys guess as we start adding a little bit at a time. Nothing yet. That's 1 spoon. 2. 3. Ooh. 4. 5. See some stuff starting to happen in here. 6, 7. Ooh. 8. Someone says the water at the bottom will turn blue. Someone says the shaving cream will sink. I've lost count. It will flow into the clear water. Most of you guys are right. The blue will go down. Last count of how many we have in here. There it goes. We're adding a little faster, see what happens. See it's starting to fall through here. Flow into the clear water. You guys are absolutely right. You guys are so smart. I'm going to just start pouring. Woo! There we go. My lab assistant is very interested in what's happening. That is pretty cool. Starting to flow down through the bottom. That is our storm in a glass. And we'll add a little bit more colored water. So what do we think's happening here? What do we think this represents? Someone says it looks like an iceberg. This kind of looks like an iceberg. You see it's starting to fall through all the way towards the bottom. That is pretty cool. Might as well finish it off here. That is our storm in a glass. Someone says the shaving cream will change to blue. It did a little bit. I didn't even think about that. Good call. Okay, so what is this experiment representing? What did we learn here? So this comes from sciencefun.org. Clouds in the sky hold on to water. They can hold millions of gallons. The layer of shaving cream is our pretend cloud in this experiment. The shaving cream layer can also hold on to water. Clouds can't keep storing more and more water forever. Eventually they get too heavy. When that happens, the water falls out or precipitates as rain, snow, sleet, or hail. So our shaving cream was our cloud, and as we added more and more water, we couldn't hold on to it anymore and it started to precipitate. You might want to try more water and less shaving cream, or less water and more shaving cream. Which looks more like a drizzle, and which one looks like a downpour? So when I was doing this experiment, this made me think, why do clouds, when they're about to rain, why are they gray? I was very curious. So this is from livescience.com, or livescience.com. It says rain clouds are gray instead of white because of their thickness or height. That is, a cloud gets thicker and denser as it gathers more water droplets and ice crystals. The thicker it gets, the more light it scatters, resulting in less light penetrating all the way through it. The particles on the underside of the rain cloud don't have a lot of light to scatter to your eyes, so the base appears gray as you look on from the ground below. This effect becomes more pronounced the larger the water droplets get, such as right before they're large enough to fall from the sky as rain or snow, because they become more efficient at absorbing light rather than scattering it. So that is pretty interesting. So I encourage you, if you like this experiment, to research more about clouds and rain and precipitation, because there's so much to learn when it comes to that. This is just a small experiment about how clouds hold water, but there's so much information out there about how clouds work, which is really cool. Okay. Someone says it represents thunderstorms. Yes, absolutely. Good call. Okay. Our next experiment, I won't tell you what it's called because I want you to guess what's going to happen. We are going to take an empty water bottle, a balloon, and you'll need some sort of funnel. You don't necessarily need it, but it'll help get our ingredients in here. We will need some baking soda, about 3 teaspoons. So I have some baking soda and a teaspoon measuring spoon. And 1/3 cup of vinegar. So I have just plain distilled white vinegar. And 1/3 a measuring cup. Usually I would use a liquid measuring cup, but it doesn't have to be exact, so I have this regular measuring cup. Okay. So first, we are going to put 1/3 a cup of vinegar into our water bottle. And with all of these supplies, I'd love to know in the comments what you think is going to happen. Someone says they love this experiment. That's awesome. It's cool to know when you guys have done these experiments before. Someone says this is super simple. Yes, it's a super simple experiment. And it's easy to do, and it helps us learn a lot. And we'll learn about why it happens afterwards. Say that's about 1/3 of a cup. I love simple experiments because it doesn't take a lot, and you get to learn a ton. So with few supplies, you can learn a bunch. So we need, I think it was 3 teaspoons. Let me check. Yes. So we are going to take our balloon and our funnel, and we're going to put about 3 teaspoons into the balloon. Someone says the balloon will inflate. That is a great guess. Any other ideas? That's 1. That went in pretty easy. That's 2. Go into the end of my balloon. And 3. Again, it doesn't have to be perfect measurements. That works pretty well. I'm going to take my balloon off of this funnel, set that to the side. And I'm going to carefully stretch the end of my balloon over my water bottle, making sure that all of the baking soda stays in the bottom here. We don't want it to hop in just yet. There we go. And you want to make sure that the balloon is nice and tight on top of your water bottle. You might need to find a smaller balloon or a bigger water bottle if it's not quite so tight. And then we're just going to lift this up, and it's going to start dumping the baking soda into the vinegar. That is super cool. I don't know about you, but I'm very excited. Inflating all by itself. Be careful if you put too much in, it might get a little too big and pop off. There we go. There's our balloon. That was pretty neat. I'm going to go ahead and take it off. Try to keep the air in there so I can keep my balloon inflated. That's pretty cool. We inflated our balloon. We didn't even have to touch it. That is so fun. Someone says they've also done this before. Awesome. It's a cool experiment. Okay, so a little bit about why this happens. When baking soda, which is a base, and vinegar and acid are mixed together, they create a chemical reaction that results in the formation of carbon dioxide gas. Gases do not have a specific shape or volume. Rather, they expand rapidly, filling their container. Gases expand rapidly because their particles move at high speeds in all directions. As the carbon dioxide gas fills the bottle, it has nowhere else to go, so it begins to fill the balloon. As the carbon dioxide gas fills the balloon inflates. The more gas that is created, the larger the balloon will inflate. The baking soda and vinegar chemical reaction will continue to inflate the balloon as long as there is still baking soda and vinegar to react. Once the reaction between the baking soda and vinegar has stopped, the balloon will slowly begin to deflate. And I encourage you to try this experiment with a different kind of acid, perhaps lemon juice. See how that works. Maybe try with different amounts of vinegar and baking soda. See how differently the balloons fill up, which fills up bigger, which doesn't fill up as much. I'm going to slowly let it out. Woohoo! Okay, so that was pretty interesting. Okay, so we have one more experiment, and then we'll check back again on our first experiment, because we have a little bit more to learn with that one. So I have, this one probably calls for the most supplies. So I have a big tray, because I have been feeling like a scientist today. I have all my supplies on my tray here. And this one is called elephant toothpaste. So I'm going to need a plastic bottle, same as I used for my last experiment. I'd use a different one just so you don't mix any of the chemicals together and get a different reaction. You'll definitely need a pan because we're going to have a little bit of spillage. So have a pan to catch that spillage that falls over. You'll need a spoon. I have some measuring spoons here that'll work for me. You'll need 2 tablespoons warm water. So that's what I have here. I started it hot, so I want to make sure it's not quite warm still. So I might have someone grab me some warm water. You need 1 teaspoon yeast. Would you be able to grab me 2 tablespoons of warm water? Thank you. I have an assistant. She doesn't want to be on camera. I will need 1 teaspoon of yeast. So I just got this little packet of yeast at the store. They only had organic, but I don't think it makes a difference. If you have both, try with both. Let me know if there's a difference. I'll need 1 teaspoon of that. So I have a little teaspoon. I will need half a cup hydrogen peroxide. So be careful. Make sure you have a parent with you if you're using hydrogen peroxide, because if you leave it on your skin too long, it can hurt your skin. So this is the kind from the grocery store. It's 3% labeled here, but you can also use 6%. You'll get a little bit of a different reaction. The 6% you get at like beauty supply stores that you can use to dye your hair. But this is the kind that you can get just at any grocery store. So we have this 3% hydrogen peroxide. A little bit of food coloring. You don't necessarily need food coloring. Thank you. Is this too? You want it exactly too? So you're just going to scoop it out of them. Thank you. Sorry. I need to give her some more instruction. That's my fault. I'll need some food coloring. Again, that's optional. And a squirt of dish soap. So I have Dawn, but any dish soap will work. Okay, so let's go ahead and get started. Thank you. So I have my 2 tablespoons of warm water. I'm going to take 1 teaspoon of yeast, which I have in my packet, and mix until the yeast is completely dissolved in the water. I only need 1 teaspoon of this. Put in the water, and then just use my teaspoon to mix it and make sure it all gets dissolved. And based on the supplies we're using and the name of this experiment, go ahead and type in the comments. I'd love to know what you think will happen. Okay. That looks like it's mostly dissolved. A little bit more stirring action. Okay. There we go. Set this off to the side. And then I will need half a cup of hydrogen peroxide. So I have my measuring cup. I'm going to measure out half of a cup. And again, if you're using hydrogen peroxide, make sure you have a parent with you or parent's permission, or any responsible adult. So we have half a cup. I'm going to take our empty water bottle and pour half a cup carefully into the water bottle. There we go. And then we're going to add a few drops of food coloring into the bottle. So, what color do I want to use this time? Maybe I'll go with Girl Scout green this time. This is a few drops. That's about 3. I'll give it a little stir there so the color distributes evenly. Next, we're going to add a squirt of dish soap into the bottle. So I have my Dawn dish soap. Welcome back, my lab assistant. Add a nice generous squirt in there. I know, isn't that cool? Thank you for joining. Hey, okay. And then I need to, once I have that, I'm going to actually give that a little stir too, make sure it's all nice and combined in there. And then all I'm going to do now is pour my yeast mixture into the bottle. Okay, buddy. Okay, so I'm going to put, I have this teeny tiny measuring cup, which is adorable. So you can use a funnel again for this. I'm going to use this little measuring cup so that I can pour it into my water bottle because it has a nice little spout. Any idea what we think will happen? I'm going to look through your comments before I go and see if anybody has any ideas as to what you think will happen. Someone's asking if these videos are available on a different platform. Yes. It takes a couple days, but we will have this posted up on our YouTube channel as well. So you can go to YouTube and just search GSWPA. We can also link it in the comments. And you can see all our videos on our YouTube channel as well. Okay, let's go ahead. Here it goes. Woohoo! Make sure you have a pan because we do have some spillage. That is pretty cool. And if you touch it, which it is safe to touch, it's just soap and air and water. It is pretty warm, which is also cool. They call this elephant toothpaste, I believe because of the consistency. It looks like toothpaste coming out of the top of the bottle. Someone says it will come out of the bottle slowly. Yes, you were correct. Awesome job. And it smells like Dawn dish soap. And I'm very glad that I had a pan. Super cool, right? So we're going to learn a little bit about why this is happening. And I can see that it's still coming out of the top, which is fun. And I do have a towel. Again, I knew this would be messy. Smells good though. Smells like dish soap. Okay, so let's learn a little bit about why this happened. So this experiment shows a very impressive and fast chemical reaction. Hydrogen peroxide is a combination of hydrogen and oxygen, or H2O2. In this experiment, yeast is a catalyst that helps release oxygen molecules from the hydrogen peroxide solution. A catalyst is a material that increases the rate of a reaction, so the release of oxygen molecules in this experiment happens fast. The foam created in this chemical reaction is made up of very tiny oxygen molecules. These bubbles result when hydrogen peroxide, H2O2, is broken down by the yeast into water, making it H2O and oxygen. Water and oxygen. Water is H2O and oxygen is O2. Someone says that was fun. Yes, very fun. During the reaction, feel the bottle. It will feel warm to the touch because it is an exothermic reaction. An exothermic reaction is a chemical reaction that releases energy through light or heat, in this case heat. The reaction will continue and foam will be produced until all the hydrogen peroxide has been broken down into water and oxygen. The foam is safe to touch because all the foam is just soap, water, and oxygen because it's been broken down. Try adding more or less yeast when doing the experiment again. How does this affect the amount of foam produced? So again, you can try this experiment a couple different ways and see what happens and see what you learn from that. Okay, got a little foam in my hair. So I'm going to set this to the side. This will be a cleanup project later. And I want to check in on our first experiment. I'm going to go back and see what happened and why it happened. Okay. Here we go. We've got what we started with, our blue and our red, and in the middle we have purple. The water walked from the blue and the red over to the purple. I think we created a beautiful purple color there. Great choice, guys. So I have a little explanation because as you might have noticed, actually I'm going to let you guys guess. What have you noticed other than the water changed colors? What do you notice about all three glasses? Any ideas? What do we notice about all three of these glasses of water that I didn't expect until I did this experiment and I saw it? Super interesting. What do we see? Go ahead and type in the comments and let me know. I see one right answer so far. Good job. So, as you can see, they are all level now. And I was very curious as to why that happened because that was something that I didn't expect. So this comes from sciencebuddies.org. Once the three cups have equal levels of water in them, the driving force for moving water from one cup to another cup has equalized. The system of cups, water, and paper towels wants to evolve to an equilibrium state, which is a state where the forces that drive the water to move from one cup to another cup are all equal. The difference in the height of the water in the cups creates a driving force that moves water from one cup to another cup via capillary action, which we've talked about before. It's the same thing that takes water from the ground and pulls it up into roots of trees, or any plants really. But once the water levels are equal, the driving forces are equal, so the system looks like it is no longer changing. In actuality, individual water molecules continue to move between the cups via capillary action. However, there is no longer net movement of water from one cup to another. So super interesting. It makes me wonder if I kept it like this for a while, if all of these would eventually be like a purple color, because we'll start moving back and forth. So I'm going to leave this out. Let me know if you guys are going to keep yours out for a while. Come back to Facebook or YouTube and let me know in the comments what happens with yours. But that is pretty cool, and I love the purple color that we made. Okay, so that is the 4 experiments that we're doing together, but I actually have one more surprise experiment, and it's a little finicky. I'm not sure if it will work, so if it doesn't work, we're going to link to a video of it in the comments so you guys can check it out, but I'm really hoping that it does work. So I will be right back with our surprise experiment. So I have a bottle of water here that's been in my freezer for about 2 hours, maybe a little bit over. I'm going to open it really, really carefully. I'm going to pour it in my glass, again very carefully, in case you want to try this at home. Almost all the way to the top. Right about there. And I have a little piece of ice. Drop it in. Hopefully it works. You may be able to see it crystallizing. You can see the crystals starting to form. I'm so happy it worked. It's a little hard to see, but I'll show you. I'll scoop a little bit out. So I didn't want to ask you guys to do this because, again, it's a little finicky. It doesn't always work. Your water has to be a very specific temperature. You can see that now that I've put the ice in, I have slush. I'll pour it in here so maybe you can see better. It's created like a slushy. So pretty cool. If you want to try it on your own, you can put a bottle of water in the freezer for about 2.5 hours. But you might have to do some trial and error like I did to get it to just the perfect temperature. And we do have a video of it we can link in the comments called Gain Elsa's Magic Touch. I think they just put it in the comments now if you want to see another video of that, in case this one was a little bit hard to see. But I'll explain a little bit about what happened in this experiment. Okay, so in this experiment, we saw something which is called supercooling. Supercooling is a state where a liquid below its freezing point, so water 32 degrees Fahrenheit, it's below its freezing point, but remains in its liquid state. Then all you need is a catalyst, so for us it was a piece of ice, to start a chain reaction and watch the liquid freeze over. So that was something called supercooling. So feel free to check out that video. And that was our last little surprise experiment. If you want, feel free to try it out on your own. But again, it doesn't always work quite right because you have to have it at the perfect temperature. You have to be very careful when you handle it because even if it's liquid, if you move it too much, it'll start to freeze right away, which did happen to me with one of my bottles of water. But something super cool. So with that, that is the end of today's virtual patch programming, Mad Science. We will link in the comments where you can purchase your patch. It's just a little form that you fill out, or you can call our 1-800 number and talk to one of our retail people. But that's it. You have earned your Mad Science patch. If you have shared this with a friend or family, you've done your take action. Or you can put on your own science show after this. Maybe tonight you want to show your parents what you learned, or create a guide with these different experiments, how to do them, what they mean. You can watch this video again, or you can search online with your parents' permission. But after you've done that, you've earned your Mad Science patch. So thank you so much for joining me for this science experiment day, and have a great rest of your day. Bye, everyone.